Welcome. I'm Bill Wake. We're here doing a weekly summary. It's something I'm trying new, but last week I started a project on a Kaleidoscope for my iPhone, and I wanted to walk through just kind of a demo and code review of that. So for now, we're going to start with a static image, and this is just a picture of something we bought at the farmer's market one day. What we'll do is we're going to start with that image. I'm going to trim it down to a square size. If you imagine a phone, usually they're rectangular, so we want to produce a circle, so we'll get it down to a square. And I'll take an image and I'll take a slice out of it. So in this case, this is 1/8 of a circle. I guess that's 45 degrees. We've just taken a center point on the image and made that sort of triangular slice out of it. I'm calling it a piece of pie. All right, but we'll take that image and then we'll reflect it. And, as if kaleidoscopes have mirrors inside, so a mirror reflection of that. And you can see the corn on the right edge, which the corn on the left edge, and the limes and tomatoes in the middle or whatever. All right, and then we can repeat. And if we, fill out and keep repeating those images and reflections, we get something that looks like a kaleidoscope image. So that's a good place to be. All right. So that's the basic math that's going on for what we're doing. Take a snapshot of a piece of this thing and then reflect it around until you get a circle. All right. Now, the next issue we ran into is what piece are we going to show? So the one just now, it showed a fair bit. I mean, you could see some tomatoes, some lime, and some corn on there. We basically take a triangle out of it, or a pie shape out of it. And that's going to, whatever that covers is going to be the heart of the image. Now, that was a good thing. But one thing I realized along the way is that sometimes you would take something and you would get a lot of white space. So the part that overlaps the image, that would show up, the tile on the floor, I guess. But then you'd have white space around the edge. And you'll see we've still got a little bit of that going on, but I tried to do some things to detect that. So same thing can happen to you horizontally. You've centered your triangle, the point of your triangle is outside the image and there's lots of white space. And you could even get, you could put the far left edge of that triangle on the far right edge of the image and get no view at all. All right, so we have some adjustments to do to try and keep that in bounds. You'll see we didn't quite succeed. The second problem we had is, it's fine to take that static picture of an image and it looks cool, but with a kaleidoscope, you want to be able to rotate it. And so the question is, if I rotate the image, how does that affect what gets shown? And my sort of compromise, because I'm not showing the whole image, I have this notion that I'm going to map the rotation angle to where on the image the bottom of that triangle goes. So the sine waves there, my idea was if I had, an infinite number of sine waves, they would cover the whole image and I could get to any point as being the base point for my triangle. I'm actually using a smaller number, I think 10, but I'm going to take whatever rotation you give me. I'm going to map the degrees of it, scale it to the image size. So horizontally, I'm going to take an X point, an X position on the image, and then I'm going to take the sine of that and get to the Y point. So you're basically sort of scooching up and down the image when you do your rotations. Okay. And that gives us some kind of approximation. Now, I don't know in the long run, once I move beyond static images, do I really need to do this? I don't know. We'll see. All right. Okay, so let's see this thing in action. I've got it running over here. And with the emulator, if you hold down Option, you get these 2 points. And that's to simulate 2 fingers so you can do a rotation. So we can rotate through our image. And you saw, oops, there's an artifact. getting too close to an edge. But on the other hand, this is very cool as far as kaleidoscopes go, right? You definitely get that feeling of as you rotate a kaleidoscope, the image is flipping and shifting around. Okay, so it's a good experience there. I mean, I like it. Let's see, yeah, something like that. You know. All right, then another thing I can do here is right now I'm doing 3 mirrors, or well, you know, you can see it. It repeats 3 times. So let's bump it up. All right, it's the same demo image, but now we've got 10 repeats, and I think that's a very cool looking. Yeah, I don't know if. Yeah, I mean that definitely gives you a kaleidoscope sense. Okay, so I'm happy. A good start. All right, so let's see how it's done. First thing, we're going to start up at the content view, which is kind of the top level view, and it's in Swift UI. Well, in Swift, a struct is a sort of immutable record type, but in using it in a view, you do have state you need to manage. So this at state says, it tells Swift UI like, hey, keep track of this state somewhere for my view, even though the view itself is immutable and can be thrown away and reconstructed or whatever. It's got no state of its own. If it did, it would get thrown away, and that would be a problem. So I'm giving it some state. One is the angle, which is the rotation amount, and the other is the number of mirrors. I guess I'm calling it number of mirrors. I don't know if that really is what it is physically, but we got 10. This is a 10 spike thing. All right, and then to make it work, there's a helper thing that's the rotation, and basically you can just create. There's a gesture, rotate gesture, and whenever it changes, it calls you and lets you do something. And what I do is I save the angle. Okay, so when I was twisting around, this rotation gesture was picking that up and saving that angle. All right. And then in the body is the main drawing. Okay, so Geometry Reader lets me get access to the size. Tab View is to do the controls on the bottom, but the real heart of this is Kaleid View. And notice there the count mirrors, so that's feeding in the 10 that's here. All right, and all I've done for that is I've got a hard-coded image demo, and it's resizable, and I set the offset. So this is that transformation from the rotation to a point on the image, okay, based on those sine waves. And all this is done basically whenever rotation detects a change, it updates the angle, and Swift UI knows, hey, I've got to reconstruct this Kaleid view. And so it calls all this stuff and gets the updated view. Okay, so most of what I've done with this, I've done just in UI, but there's one exception so far, and that's this angle computation. So the converting from the box with all the sine waves in it, that's this code, angle to X, angle to Y. All right, and let's take a look at that. Well, let's start with tests. Okay, so to try and prevent the stuff from going off the edges, I've said I'm only going to go from the low to the midpoint. Okay, so imagine that wedge. It's kind of leans to the right. I can stick it all the way to one side or most of the way to one side, but I don't want to go too far to the right or it goes off the edge. I don't know if I've got the right bounds. It was mostly empirical, I would say. I mean, I kind of reasoned my way to something and then kind of made some adjustments based on just kind of intuition, I guess you'd say. So I expect that you'll never use less than 3 mirrors, and the more you use, the better. So this maybe should be a third, might be a better thing to make sure I just only take from the first third of the image or something. But I'm taking something more or less out of the middle. and I'm testing 0, pi, and half pi. So I don't know if you remember trigonometry at all, but a circle is 0 to 2 pi, wraps around the whole way. So 0 to pi gets you the top half of the circle. Okay, and so 0 is going to map to the min. Pi, 180 degrees, is going to map to the max, which I'm only going to 50%. And then half a pi is 90 degrees, and it wraps part way. And then if it's negative, I wrap it around, and and if it's well negative, I also check that negative pi, which is 180 degrees coming from the bottom side, maps to 0, and then negative half pi to 12 and a half, and pi wraps around. Okay, so basically the bottom half of the circle gets the left half of the image, and the top half of the circle gets the right half of the image, and that's that map. So those tests get that map. Let's look at angle to x. You pass in self is the angle, and then size is the size of the room you have. Okay, and we're trying to deal with the x-axis. So I've basically taken the size width divided by 4, and then this stuff wraps around. So if it's too negative or too positive, it wraps around to the normal range of 0 to 0 plus or minus pi, I guess you'd say. And so this thing basically scales by the image size to the position corresponding to the angle. Okay, dividing by pi kind of converts it back from radians to a percent. All right. And then the next one is the y one, and that's the one with the sine waves in it. So it's a little weirder. The code's actually simpler, but okay. So angle 0, we're going to map that to a y value of 25, and where 25 comes from is it's limited off the height, because the height is the smaller. Okay. Let's see, 0 maps. So yes, it's mapping to the x. 0 maps the y to the x value, so that's a little funny feeling. Okay. But it also deals with the repeats. So if you have something that's multiple repetitions, sine of 0 is 0, sine of 2 times 0 is 0, sine of 10 times 0 is 0, sine of n times x is still sine of x. Okay. Because sine repeats. And we're just checking through these values of, does it map where I want it to? Okay. And then finally, going deeper into the repeats, I'm going to take a particular size, I'm going to take an angle, and then I'm going to divide the circle into 10 parts. So if I take whatever value I get at 18, it's an arbitrary value. But I add 1/10 of a circle or 2/10 of a circle. If the repeats are 10, that 10 is the same, basically. It should have the same y value for that. So we check that. And then on the code side of it, it's much simpler. We take a scale factor, size width divided by 4, and the repeats, so the sine is n, which repeats, times the radians of this of the angle that we're on. Okay, so basically just kind of scaling that value, and giving it a base of size width over 4 plus a scaled sine value. It seems good, so it's a start. All right, so let's go back here and work out the way the image works. So we're taking our image and passing that to a kaleidoscope view. So we've got an image. It's resizable, so it stretches out to fit the whole screen. And then we took an offset, which said, where do we want to put that triangle, the piece of pie that's going to form one little piece that gets reflected and repeated around. Okay, so the image goes in, and then we can go see Kaleidoscope view. Here's Kaleidoscope view. All right, so its job is basically, I need to know the count, like how many of these things do you want? And it's kind of the mirrored things, all right, because they will come in pairs when they're reflected, all right. But all it's doing is it's basically this repetition. I'm going to take the images in the count. I'm going to show the mirrored clip to the pi, and then for each one, I'm going to rotate it around proportionally to the angle that we got in. So if it's 60, our count is going to be 3. Okay, because like the original had 3 repetitions, 60 degrees for the piece of pie, 60 degrees for its reflection, and then that repeats 3 times. So you'll see the angle here is determined by the rotation angle. So we've got the count, and we're just multiplying by the rotation angle. So 0, 120, 240, and then you're back around. Okay, so this does those repetitions that make all these. Okay, so I just have a little system image heart, and I've repeated it 3 times. Not terribly enlightening. Okay, so but anyway, you can see the 3 repeats in there. All right, so what it's repeating is a mirrored view, and this is very minimal. Okay, so it just takes whatever you give it for a view, and it's in a Z stack. So they overlay each other. But all I've done is take the content, and then the content scaled by -1 on the x-axis reflects it horizontally. And this is because we took pi that comes down, is sort of starting in the middle and slicing vertically to the side, reflecting it horizontally makes it look right. And then because it's a clipped shape, it's not going to overlay itself. It repeats, okay, or it when you flip it, it touches the edge, okay. And in the demo, the preview, I'm doing that with our image and just a 2-piece pi count, so it's reflecting once. It's just half the image gets shown, okay. And then what was passed to that was the image clipped to the pi, okay. Now, this was challenging to get right. There's a lot of ways to draw it wrong, and what got me most was they put the y-axis, y equals 0 is up here, and x equals 0 is over here. Instead of like every geometry textbook you ever did from, grade whatever to now, always puts, the y-axis starting at 0 on the bottom left. So it took me a lot of flipping things around and doing things. Finally, I said, well, let's just scale the whole image by -1 so that it's working, as if this were 0. It's not really 0 is still here. You're actually working on the area above the phone at that point. But I could flip that and use my normal brain for coordinates, pretend it was down here, and get it to work. Gosh, I don't know why that decision they made. It just is killer for this sort of thing. I think either bottom left or maybe physically centered on the screen. Either one would be completely fine from my point of view mathematically. But so I basically did this, flipped, and then translated it back down so it'd be visible on the phone again, and then refactored it to do it properly. So properly is going to look a little funny. So let's walk through it. Here you can see minimum dimension. So this is because we're going to build a circle. If we want to see it, it's got to be, the radius has to be the smaller dimension of either the width or the height. Okay. And we have the center point. We reference it a couple times, so we'll do that. Actually, we don't reference it that much now, but okay. And the angle. So if we take 2 pi, that's the whole way around the circle divided by the count, we'll get the angle corresponding to the piece. So to build a shape, at least one way is you make a path. So create a path, move to the center, add a line from the middle X, which is here, and our Y is going to be the middle Y minus that minimum dimension. And the reason it's minus is because 0 is up towards the top. So we're taking the radius, which is min dimension over 2, and we're subtracting that from the Y coordinate, and that gets us up here. Then we're adding an arc to do this. The arc is centered here at the center of the image. The radius is min dimension over 2, which seems like I should maybe make that call a variable. All right, min dimension over 2, and the radius. The angle 270. Well, this is, again, you're going to have to kind of flip your image around, and normally 270, if your 0 is down here, 270 is this one down here. But for us, because 0 is here, this is 0 and this is 270. Okay. And then the end angle is that plus these radians, and then clockwise or not. Well, again, it seems like, going here to here is clockwise. Yes. What's the problem? Well, you're backwards because you're upside down. And then closed subpath says, okay, you did your arc. Now go back to the start. What's coming up this week? We're doing a little bit of work around the tabs, and I want to select your own image. I'd like to have you start at the image and just rotate your phone around instead of this pinch rotation. And like I said, I want to get to live camera and 3D shapes. So I expect we'll be on this for a few more weeks if I decide to keep going that far. With the Twitch sessions, they're Monday through Thursday, 2 to 4:30 p.m. Eastern, or 6 to 8:30 p.m. UTC. You can go to xp123.com/Twitch, and that'll bounce you over to the Twitch view. And thanks for watching, and take care. Bye-bye.